Welcome back. Today we're basically opening up the ultimate chemical recipe book. We're going to figure out how to make almost any salt you can imagine, pretty much from scratch. And trust me, it's a lot easier than you'd think once you know the secrets. So let's just dive right into the world of salt making.
All right, first up, a little question for you. Think about what's in your medicine cabinet. You've probably got Tums for an upset stomach, maybe some Epsom salts for a bath. So what's the secret connection between these two really common household items?
You guessed it, they're both salts. And the cool part is the chemical principles that are used to make them in a big lab are exactly what we're going to cover today. So by the end of this, you'll have the blueprint to make either one of them.
Okay, so let's get our main definition down. In chemistry, a salt isn't just what you sprinkle on your food, right? It's a specific kind of compound that's formed when the hydrogen in an acid gets swapped out for a metal or an ammonium ion. Understanding this one little swap is basically the key to everything else.
Now, before you even think about mixing anything, there is one question you have to ask yourself. And this is the most important step, because the answer tells you exactly which recipe to follow. And that question is, simply, does the salt you want to make actually dissolve in water? That one little question splits all salts into two huge families. You've got your soluble salts, which, dissolve super easily in water, and then you have the insoluble ones, which don't. They just stay as a solid. And depending on which family your salt belongs to, you're going to use a completely different method to make it.
You're probably thinking, okay, but how am I supposed to know if it's soluble? That is an excellent question. And this table is your guide. The big takeaway here is that some rules are just set in stone. See how any salt with sodium, potassium, or nitrate is always soluble? No exceptions. But for others, like chlorides and sulfates, you've got to watch out for a few tricky exceptions. So this table, this is your cheat sheet.
Okay, so let's start with the insoluble salts, the ones that refuse to dissolve. The recipe for these is called precipitation, and it's actually really cool to watch happen.
The whole idea is just brilliantly simple. You take two soluble salt solutions, mix them up, and they immediately do this little chemical dance where they swap partners. And when they do, they form a brand new insoluble salt that just appears out of nowhere as a solid. And we call that solid the precipitate.
Let's make this real for a second. Let's say you want to make lead chloride, which we know from our chart is insoluble. Well, the recipe says we need a source of lead ions and a source of chloride ions. So you could just take a solution of lead nitrate, mix it with a solution of good old sodium chloride, and bam, you get your solid lead chloride just like that.
And the process itself is just 4 easy steps. First, you mix your two solutions. Second, you pour that whole mixture through a filter paper that'll catch your solid salt. Third, you give that solid a good rinse with some pure water to wash off anything extra. And fourth, you gently dry it out in an oven. And that's it. You've made an insoluble salt.
All right, so that's the insoluble ones sorted. But what about the salts that do dissolve, like the Epsom salts we mentioned at the beginning? Well, for those, we have a totally different toolkit of options.
There are basically 4 main recipes in this part of our cookbook, and they all have one ingredient in common. You start with an acid. You can react that acid with a soluble base, that's also called an alkali, or you can react it with an insoluble base, a metal carbonate, or even a reactive metal all by itself.
Now, the most precise method here is called titration. This is the one you pull out when both of your starting ingredients, the acid and the base, are soluble. It lets you mix the exact right amounts to perfectly cancel each other out, leaving you with just your salt and some water. No leftovers.
And here's what that looks like in the lab. You use this long, skinny tube called a burette to add the acid drop by careful drop into the flask with the alkali. You also use a special indicator that changes color the instant that the neutralization is perfect. Yeah, this method is all about precision.
But hey, what if your starting base, metal or carbonate, is a solid? Well, then it gets even easier. You literally just keep adding the solid to your acid until the acid is all used up. You'll know it's done because it stops fizzing. And since you added extra, you just filter out the leftovers, and what you're left with is a pure solution of your soluble salt. Easy. Okay, I know we've covered a bunch of different methods here. Precipitation, titration, adding extra. It can feel like a lot to remember. But what if I told you there's one single diagram that just puts it all together perfectly?
And here it is, the master key. This flowchart is your decision map. It takes everything we just talked about and puts it in one simple place. You just start at the top with the salt you want to make, and you answer the questions. Is it soluble? If no, Boom, you're doing precipitation. If yes, are your ingredients also soluble? If yes, it's titration. If no, you use the add extra method. It is that simple, a foolproof guide every time.
So why does any of this even matter, right? Why is it so important to know how to make salts? Well, it's because the second you leave the lab, you start seeing them absolutely everywhere.
Seriously, just think about your day. You sprinkle sodium chloride on your food, you might take Tums, which is calcium carbonate, or use Epsom salts, magnesium sulfate, the fertilizer for your garden, probably an ammonium nitrate salt, and that toothbrush you used this morning, it's got sodium fluoride in it to protect your teeth. They are literally the building blocks of our modern world.
And this brings us right back to the beginning. That reaction that happens when you take a Tums, it's a classic neutralization reaction. You've got a base, the calcium carbonate, reacting with the extra acid in your stomach to make a harmless salt and water. It makes you feel better. You're basically doing a salt preparation inside your own body.
So there you have it. You have the cookbook, you have the master decision map, you get the recipes for making pretty much any salt there is, from the super simple to the complex. So I guess the only question left is, what salt would you make first?